This wonderful graphic explains how inflation is measured by two measures of inflation. The GDP deflator, which is here in red, and the other one is the CPI, which is here in blue. As you can see, they are pretty close because they measure essentially the same thing. Remember that the GDP deflator takes inflation out of our production calculations. On the other hand, the CPI measures the weighted average of prices of a basket of consumer goods and services. It is clear that both of them are pretty close to inflation. They suddenly move in the same direction over time. There are some important contrasts between CPI and GDP deflator. Even though they both essentially measure inflation, they do so in three different ways. First one is imported consumer goods. Imported consumer goods are one of these imported things that are adjusted here. Imported consumer goods would be included in the CPI, but remember that in GDP deflator, we subtract imports from our total GDP calculation. So imported consumer goods are going to be excluded from the GDP deflator. Number two is the capital goods, such as tractors and factories, which are used to make other goods. Those are going to be excluded from the CPI. If you can remember, in market basket, we didn't see things like capital goods. We saw household goods like clothing and food, things like typical consumer buys. Things that are capital goods business would buy are going to be excluded from the CPI and included in the GDP deflator because those are related to the production if they are produced domestically. And you need to focus in this point. When we say if they are produced domestically, it means if they are imported, it means it will be excluded from GDP deflator. Number three is the basket. The basket that created by both of these measures. The CPI basket uses a fixed basket, and GDP deflator uses the basket of what is being currently produced goods and services. It meters if different prices are changed by different amounts. So there are some significant differences here. Here is an opportunity for you to practice this little bit of exercise about what's going to be included and where. Here in each scenario, they want you to determine the effects on CPI and GDP deflator. Let's have a look at the scenarios. Scenario A says Starbucks raises the prices of frappuccinos. Scenario B, Caterpillar, you can see the following picture for a better understanding of the meaning of Caterpillar. However, Caterpillar raises the price of industrial tractors that are manufactured in Illinois. Scenario C, Armani raises the price of Italian jeans that is sells in the United States. You need to focus here that these jeans are not produced domestically. It is produced in Italy. For each of these scenarios, if you want to stop the video to answer them, then check your answers to make sure that you are comfortable with this concept. We will answer this exercise together, but it is better that you take your time to try to answer them by yourself. Let's see and compare your answer together. For scenario A, when Starbucks raises the price of frappuccino, both the CPI and GDP are going to be included in that measure. It is something that is produced in this country and parts of the CPI measure under food or consumption, something like that. For the scenario B, that's clearly going to be part of GDP because it is a capital goods. But remember, the CPI doesn't include capital goods like this. For that, your GDP deflator is going to be affected by it, but CPI will not because it's not part of the market basket for consumer. For the scenario C, Armani raises the price of the Italian jeans that is sells in USA. It is going to affect the CPI because this is clothing, which is one of these parts of the market basket for CPI. But because it is an import, so it is not going to affect GDP. Because if you can remember, we studied in the previous chapter, imports come out of GDP measure. It is the net export minus imports, so imports will not be counted here. Here we are going to look at how we correct variables for inflation. This allows us to make comparisons from one time to another. As you know, inflation raises the general level of prices and in turn reduce the purchasing power of money. In simple terms, imagine that you have 1000 reals. You could buy a dish of eggs last year with this 1000 reals. But as a result of inflation, the price of a dish of eggs today is 1200 reals, meaning that 1000 reals gave you last year a dish of eggs, but as a result of inflation, the purchasing power of money has decreased, and now you can no longer buy the same things that you could buy in the past. In the following example, we will correct the inflation variables to know the purchasing power of any amount in the past versus its purchasing power today. In the example given here, the minimum wage in December of 1964 is $1.15, and in December of 2007, the minimum wage is $5.85. The question in this exercise is whether the minimum wage that workers earned in December 1964 had more purchasing power than the minimum wage that the workers earned in December 2007. At first glance, people may think that, of course, the minimum wage of $5.85 is absolutely more than the minimum wage of $1.15. People would say it is better to have a higher minimum wage. To know the answer, we can adjust for inflation to find out what that $1.15 would have purchased in 1964 versus that the 5.85 would have purchased in December of 2007. It is a comparison. We are going to use the CPI to convert the 1964 figure into 2007 dollars. And here is how we do it. To find out the answer, we will need to know the CPI for the year 1964 and for the year 2007. What should be given at any exercise? In this exercise, the CPI for the year 1964 is 31.3 and the CPI for the year 2007 is 211.7. Using the following formula, we will know the purchasing power of any year we want, which we will call it in this formula the year T. In this example, the year 1964 is the year T, in which we want to know the purchasing power of the minimum wage. The formula says to know the purchasing power for any year equal the amount you want to know, its purchasing power, which we donated by the year T, multiply the CPI for the current year divided by the CPI for the T year. It's by taking the data from the exercise and apply them to the formula, it will be equal the amount for the year T is 1.15 multiply the CPI for the current year, which is 211.7, divided by the CPI for the year T, which is 31.3. So the result will be 7.78, which means that the purchasing power of minimum wage in 1964 had more purchasing power than the purchasing power of minimum wage in the year 2007, which is 5.85. Researchers, businesses, analysts, and policymakers often use technologies to convert nominal figures, which would be in today's dollar, into constant dollar figures, which would be real. And now we can see what those constant dollar are really worth and what they will buy in terms of today's dollars. And that way we can see how a variable is changed over time with that inflation corrected. The previous example of minimum wage was a perfect example of what we have talked about now. Here in this nice graphic of the minimum wage, we can see the minimum wage for the years from 1950 to the year 2005. And it's clear that the minimum wage has been increasing continuously during this period. What you see here is the nominal dollars. In this drawing, what we are seeing is the real purchasing power in terms of today's dollar. We see it in constant dollars, meaning we take the effects of the inflation out. Obviously, after getting rid the effects of inflation, the minimum wage was raising and feeling as a purchasing power, unlike what appears as the nominal dollars that shows that the minimum wage was constantly raising. Here we have an exercise that resembles a previous solved exercise of correction of inflation variables. Try to do this exercise by yourself. You can pause this video until you are done with the exercise and then compare your answer. The last thing we are covering in this chapter is correcting the variables for inflation using an index. So a dollar amount is indexed for inflation when it's automatically corrected for inflation by law or an contract. So there are laws that automatically will index, which means compare one thing to another. Index that the cost of living adjustment for Social Security. For example, the law states that the cost of living will be adjusted and indexed for the inflation rate. And so that is very common to find that the CPI is that index used and it automatically determines the cost of living adjustment in labor contracts and social security payments and federal income tax brackets. Last part of this chapter is the understanding of real and nominal interest rate. But before that, we need to understand the meaning of the interest rate. The interest rate is the amount a lender charges for the use of assets expressed as a percentage of the principal. The interest rate is typically noted on annual basis, known as the annual percentage rate. In simple terms, the rate that the bank gives you in exchange for depositing your money, or the rate that the bank takes from you in exchange for giving you a loan. For example, if you have $1,000 and you deposit it at Arab Bank announced that it would give an annual interest rate of 12%. The bank will give you for depositing your $1,000 $120. The 1,000 multiply 12% equal $120. So by the end of the year, you will have your $1,000 plus the 120. So you will have $1,120. The 12% here called the nominal interest rate. The nominal interest rate is the interest rate not corrected for inflation, the rate of growth in the dollar value of deposit or debit. But what is the real interest rate? The real interest rate is corrected for inflation, the rate of growth in the purchasing power of a deposit or debit. To understand the meaning of the real interest rate, imagine that you have $1,000 and deposit it at the bank. That gives 12% a year as an interest rate. So you will have, by the end of the year, $1,120. But on the other hand, the inflation rate in your country that year was 10%, which means that the 1,000 you deposited at the beginning of the year, its purchasing power decreased by the 10% as the result of the inflation. What happened to your money is that your money had increased by 12%, the interest rate from putting your money at the bank. On the other hand, it had decreased by 10% as a result of the inflation. In order to know the real interest rate for depositing your money, we will apply this formula. The real interest rate equal nominal interest rate minus inflation rate. So the real interest rate here is 12% minus 10% equal 2%, meaning that the real interest rate you got as a result of leaving your money in the bank for a full year is only 2%. In this slide, you will find another exercise for what was explained a little while ago. You can see it and try to solve it on your own. Here is a graphic of nominal and real interest rates. Over the period from 1950 to 2005. You can see that they are related. Furthermore, it's interesting because they have similar patterns. But for a specific period of time, they had inverse relationship. What you can see right here is this period of time from about 1970 to about 1980, maybe the mid of 80s. The USA had a period of massive inflation, so the really interest rates were really affected by the very high rates of inflation. The rest of the time, as you can say, they are pretty much same. I can guess what exactly caused this crisis in this period, especially in 1973, when Egypt and Syria used oil as a weapon against Israel. In the October War, when OPEC decided to prevent oil exports to countries that support Israel. Although the boycott lasted only 5 months, its impact has continued to date. Finally, we reached to the end of this chapter. Good luck for all of you.